Alright guys, so I'm going to work through these free fall problems that Coach Pfaff posted. Make sure you read this part. These are very important notes that you need to know. And I'll put some notes up as well on that. But I want to go down to the questions and just do those first for you guys. So here's the formulas he has listed. I have them pulled up on the side over here as well. This is a document I've been using, and I'll post this under my notes section as well. But basically, here's all the formulas that we've been taught so far and what all the variables are and what everything means and the units that they use. And then for free fall, you're using these equations with acceleration, not the ones without acceleration, but the ones with acceleration in it, although acceleration now is just going to be a negative 9.8 meters per second squared, and that's due to gravity because now we're in the y plane. Because things are either being thrown up or falling down. We're dealing with gravity now as our acceleration. So anytime you see A in the formula, now you're going to be using G. So number one says a rock falls from rest from a bridge to the water below. If it takes 2.5 seconds for the rock to hit the water, how high is the bridge? All right, so the important thing in this one is that you need to know if anything is falling, that right there from rest means that VI, the initial velocity, is going to be 0. So I like when that happens because when the initial velocity is 0, this whole section of the formula becomes 0. We can also say that the initial position is 0. So now we have the formula up here says x equals 1/2 at squared. So this formula, when something is dropped, it becomes a lot shorter into that one right there. So it says when a rock falls from rest on the bridge to the water below, if it takes 2.5 seconds, so the time is 2.5 seconds, for the rock to hit the water, how high? Well, that's a distance. We're looking for the final position of the rock. So looking at these three variables right here, we also know A, always is negative 9.8 meters per second squared when you're dealing with something in the vertical direction. All right, so looking at those four, I'm going to choose this formula right here. Again, I have taken out the first part of that formula because that information is 0. So because of that, you no longer need that part. So here's my formula. So I've written my givens, I've written what I'm looking for, and now I've chosen my formula. Now I'm going to just plug in my numbers. 1/2 A is negative 9.8. T is 2.5 seconds, and that is squared. Don't forget the squared at the end. All right, because I'm looking for x, and x is already by itself, I'm just going to plug all that into my calculator. So it's I use 0.5 for 1/2. So 0.5 times negative 9.8 times 2.5 squared is 30.6. Now, I get a negative 30, but that's just saying that if it's starting from here, it's going down. That displacement there is negative 30.6. So it asks us how high. So the bridge is 30.6 meters high. All right, then it says, what is the velocity when the rock hits the water? So you have the same information up here, but now we want to know VF. Okay, so we still have gravity. We still know that the initial velocity is 0. And we know that it falls for 2.5 seconds. So I'm going to choose VF equals VI plus AT. Remember that A is going to be your G, your gravity. VF, I don't know. VI is 0, so again, you can just remove that portion of the formula. A is negative 9.8 meters per second squared, and T is 2.5 seconds. So when I multiply those two together, I get a negative 24.5 meters per second. My final velocity, like right before it hits the ground, it's going 25 meters per sec, 24.5 meters per second. It's in the negative direction because the rock is falling down. All right. Now it asks, what is the speed of the rock? Well, the negative 24.5 from the question before, that's the velocity, because velocity is a vector, and vector includes direction. Speed is a scalar quantity, no direction. So when he asks what the speed is, it's just 24.5 meters per second. All right. Number 2, a ball falls from rest. Okay, really important again. From rest. Tells us that that initial velocity is 0. We know now that the height, the distance, is 19.6 meters. How long does it take for the ball to reach the ground? So we're solving for t. And we also know gravity is negative 9.8 meters per second squared. So solving for t, so x equals 1/2 at squared. This time I know the x is 19.6. I am going to make that a negative 19.6 because it is going down. This will matter in just a minute, and I'll show you why. All right, equals 1/2 negative 9.8 t squared. Okay, so solving this problem, I'm going to take 1/2 of negative 9.8 is negative 4.9. I'm going to bring down the t squared and the negative 19.6. All right, here's the important part of making this 19.6 a negative. When you divide this negative 4.9 by both sides, this number becomes a positive number over here, so that when you take the square root, you won't get an error in your calculator. So if I do negative 19.6 divided by negative 4.9, I get 4. And I need to take the square root of that to get rid of the squared. So the time equals 2 seconds. Okay, so just don't forget that even though it's 19.6 meters high, we're talking about a displacement, so it needs to be a negative, because it's going down, it makes it a negative 19.6. Okay, then it says, what is the velocity of the ball as it hits the ground? All right, so again, same information, but now we are looking for VF. And the VI is a 0, so that cancels. Well, it goes away. 0 plus anything, doesn't matter. So we're taking that out for now. All right, so VF equals negative 9.8 times 2. So you get a negative 19.6 meters per second. And then when it asks the speed, again, speed does not have direction included. So we're just going to say it's 19.6 meters per second. All right, number 3, write your givens. A ball is dropped from a cliff, so anytime it's dropped, we're holding it in our hand like this. There's our hand holding it. We're standing on a cliff. Dropped means VI equals 0. It's going to fall down. Takes 4.5 seconds to hit, so I'm going to say VI equals 0, time equals 4.5. How tall? We want the height, and we know acceleration is negative 9.8. Okay, so once again, I'm going to shorten that long equation because everything's starting from rest. So x equals 1/2 negative 9.8 times 4.5 squared. Okay, and when I plug that in, I'm going to go 0.5 times negative 9.8 times 4.5 squared, and I get negative. I do get a negative, but remember, that's just because it's going down, and it asks how tall, so I'm going to make that a positive number, 99.2 meters tall. All right, what is the velocity of the ball when it hits the water? Velocity is the final velocity. The initial velocity is 0 plus AT. Vf equals negative 9.8 times the time from up here is 4.5. So negative 9.8 times 4.5 in my calculator is negative 44.1 meters per second. Okay, so that's the velocity because it's negative, it's going down, but the speed would just be 44.1 meters per second because that's a scalar quantity and no direction matters there. All right, a ball, number 4, last one, a ball is thrown straight up. Okay, this time we're going up. All the other ones before we were just dropping something down. So in this case, the ball is going up. We're giving it an initial velocity of 15 meters per second to get it up there. It will fly up into the air and stop briefly. Okay, so that means at the top, the final velocity is going to be 0 as it stops. Then it's going to return to the ground. How many seconds will it take for the ball to fly up and stop? All right, so we're looking for time. We also, I'll go ahead and write VI is 15 here. A is negative 9.8. And VF is 0. Okay, so looking at these 4, I'm going to choose VF equals VI plus AT. We cannot cancel that VI this time because it's not 0. VF is 0, but we need that on this side to be able to solve for our equation. 0 equals 15 plus negative 9.8 times t. We're solving for t. So we're adding 15, so we need to first subtract 15. Cancels here. That gives us a negative 15 on that side. Bring everything else down. And then divide by a negative 9.8. Cancels on this side, so negative 15 divided by negative 9.8 is 1.53 seconds to get to the top. If we wanted to know how long it took to go to the top and then back down, because if it hits the same spot we threw it up at, then we would just multiply that by 2. Because it stops at the top, we can solve for the time going up, and then we can just multiply that by 2 to get the full time if he were to ask that, just so you know. But he doesn't in this one. So there you go.